Welcome back, everyone. It's Dr. Lindner. We are still talking about tissues. In a previous video, we spoke about epithelial tissue, and now we're going to be talking about connective tissue. Now, you should be thinking to yourself, okay, when we did epithelium, he said there was a big difference between epithelium and connective. And remember what the difference was. Connective tissue consists of cells that are widely spaced apart. They're separated by protein fibers and ground substance that's referred to as matrix. You just heard me use the word extracellular matrix. So epithelium has little extracellular matrix, whereas connective tissue has lots of extracellular matrix. Connective tissue is the most abundant and variable type of tissue that's found throughout the body. It connects organs to each other. Well, that would make sense, right? Connective tissue connects organs. It even connects the epithelium to the rest of the body. So connective tissue and epithelium connect to one another. They use something called a basement membrane. A basement membrane to connect. The connective tissue gives support and protection to our body. It gives us physical support. When I think of physical support, I think of like bones. So bones make up connective tissue. The immune system. Wow, the immune system is connective tissue. Well, the immune system is made up of white blood cells, and white blood cells can make antibodies. Pretty cool. So white blood cells. So blood is connective tissue. It's just liquid connective tissue. Okay, so blood is connective tissue because it also moves and transports materials through the body. Blood, whether it's red blood cells or white blood cells, right? Blood itself is liquid connective tissue. Connective tissue can store energy, and it's involved in heat production because of adipose. What is adipose? Adipose is fat cells. Connective tissue is highly vascularized, meaning it's got good blood supply. Epithelium, not so much. Epithelium doesn't have the best blood supply, but connective tissue is highly vascular. There's a few exceptions to the rule. Cartilage doesn't have the best blood supply. Tendons don't have the best blood supply. And ligaments. These areas have poor vascularization, poor blood supply. And you know this to be true because when you hurt cartilage, let's say the cartilage of the knee, it takes a long time for that to heal. If you overstretch a tendon or a ligament, whether you have a strain or whether you have a sprain, sprain involves ligaments, strain involves tendons, and we know that tendons are just the extension of muscle, right? Because muscles attach to bones. Muscles attach to bones by way of tendons. Bone, if this is a bone and this is a bone, these bones can connect to one another through ligaments. So these are ligaments. Ligaments connect bone to bone and they hold them in alignment. When you overstretch a ligament past its anatomical limit, it's a sprain. When you stretch a muscle or tendon beyond its anatomical limit, it's called a strain. They take a long time to heal. Tendons don't take as long as ligaments. Ligaments take a long time. Okay? So when we look at connective tissue, it's important to know that connective tissue has 1, 2, three main subcategories. There's connective tissue proper, there's supporting connective tissue, and there's liquid or fluid connective tissue. Now, we spoke about fluid connective tissue. We said that's blood, right? We have our red blood cells, we have white blood cells. That's liquid connective tissue or fluid connective tissue. When we talk about supporting connective tissue, I think of what's the main support of the human body? I think of the skeletal system. The skeletal system is made up of bones and cartilage and bone. And when we talk about bone, we're going to focus on compact bone. When we talk about compact bone, the main area is referred to as an osteon that we're going to be focusing a lot of time on. When we talk about cartilage, cartilage comes in three different flavors. Cartilage comes in hyaline cartilage, elastic cartilage, and fibrocartilage. So you see how we start to talk about these different categories, and there's more under connective tissue than there is with epithelium. So we'll give certain examples of hyaline cartilage and elastic cartilage and fibrocartilage in a little bit. Under connective tissue proper, there's loose and dense connective tissue. Under loose, there's three flavors: areolar, adipose, and reticular. And under dense, regular, and irregular, primarily. There's elastic also. We'll focus on these two primarily. All right, so you may need to use this, right? You may want to put a star on this as a reference so we know, okay, when you're looking at something, what category does it fall under? So connective tissue proper, okay, we're going to be looking at this line first, okay? Let's focus on that first. So under loose connective tissue proper, there's areolar, there's adipose, and reticular. Areolar is the part that provides padding, and it's going to separate your skin from everything that's deep to it. Like if you pinch your forearm, your skin separates from your muscle. You can't pinch the muscle at the same time. There's a barrier between the two, and it's made up of elastic and collagen fibers. These are protein fibers. Elastin, I think of a rubber band that's elastic. Collagen, I think of like steel or iron rods, right? These are for stability and strength. These are for flexibility. Adipose, these are fat cells. Now, this could be a little tricky. Here's a cell, and here's a cell. They look alike. One's going to be a squamous cell, and one's going to be a fat cell. How do we know the difference? When you see the nucleus in the center, that's a squamous cell. When you see the nucleus in the periphery, that's a fat cell or an adipose cell. Why is the nucleus in the periphery? Well, because fat cells store toxins. All right? And if the nucleus was in the middle, you kill the fat cell. Fat serves us a purpose. When people have an excessive amount of fat, it's for a reason. It's to try and save them, right? Because their environment is toxic. Whether the environment that they're living in is toxic or whether what they're putting in their body is toxic. And it's trying to prevent those toxins from hitting the nervous system too fast or from hitting the liver too fast and killing the person. If you think of insects, we do not see morbidly obese insects. Why don't we see fat insects? Well, because they don't have fat cells. You don't see a fat ant, a fat spider, a fat mosquito. That's why when these insects eat crops that are sprayed with fungicides and pesticides and herbicides, it kills them right away. because they don't have storage to store the toxin, so it goes right to its neural system and kills it. Humans, on the other hand, we can eat non-organic food, right? Stuff that's raised by a farm that's heavily sprayed with fungicides and pesticides and herbicides. Those are very much carcinogenic, loaded with glyphosates as well, and consume them. No matter how good you wash it, it's in the rooting system. You could wash it, that's if it's sprayed, but a lot of times they use pellets so it gets in the ground, gets into the rooting system, and gets into the center of the crops. So you're eating a byproduct of that. All right. Fat cells also increase in number until puberty. And that's why it's so important to watch body composition at the time of puberty. If you're a thicker individual at the time of puberty, you have a much more challenging time in body composition maintenance, right? If you're thinner at the time of puberty, it's easier for you to manage your body composition for the rest of your life. If you're thicker and you have more fat cells at the time of puberty, you have more fat cells to manage for the rest of your life. Makes it difficult. So some people do liposuction. Well, they go in there and they pull out the lipid, they pull out the adipocytes. But these adipocytes come from stem cells, and as long as you have stem cells, fat cells can come back. All right, reticular, these are also fall under loose connective tissue proper. These help provide the framework of support of a lot of your organs. Now, dense connective tissue. Dense connective, we have dense regular connective and dense irregular. The difference here is in dense regular, we're going to have these collagen proteins that are all parallel to each other, right? They're all interwoven in the same direction. So that tendons and ligaments and muscles, right? When tendons and ligaments, and you have these collagen fibers that are all aligned, that's great. It helps with the line of pull of muscles. So tendons and ligaments are closely packed collagen fibers. Dense irregular, you may have a protein fiber this way, a collagen fiber this way, a collagen fiber this way, a collagen fiber. They're irregular. They're in different directions. So that when you rub your eyeball, you don't have to just rub your eyeball from left to right. You can rub your eyeball up, down, left, right, diagonal, because the eyeball has these irregular, dense irregular connective tissue, so the eyeball shape can distort and it can bounce back. Okay. Elastic connective tissue, these are found in certain ligaments where the bones, remember ligaments go from bone to bone, like that. That's a ligament. So the vertebral column has ligaments that are loaded with elastic connective tissue because the spine has to be very flexible. The spine is very stable, so it doesn't need lots of collagen. It needs lots of elastic connective tissue. But if we look at the knee joint, on the other hand, the knee joint is very unstable. It's the largest joint in the body. The knee joint is very unstable, so the knee joint has some elastic cartilage, but it needs more strength and stability, and that's where collagen comes into play. Okay, so we've done this one already. Now it looks like we're going to be talking about fluid connective tissue, all right? So let's knock this one out of the park now. So under fluid connective tissue, we're talking about blood and lymph. We're going to focus more on blood, okay? When we talk about blood, we're talking about red blood cells, white blood cells, and platelets. Red blood cells are also known as erythrocytes. Erythro means red. Cyte means cell, so it's a red blood cell. Their primary job is going to carry blood gases like oxygen and CO2 and nitric oxide. White blood cells, leuco means white. So leukocytes are white blood cells, and they're involved in helping to fight infections. And platelets are involved in forming clots. So they help us to stop bleeding. When someone uses baby aspirin or regular aspirin, these are blood thinners because they inhibit the platelets' function. Lymph is the interstitial fluid that's found between the cells of the human body, and these are going to enter lymphatic vessels. So blood and lymph are fluid connective tissue. Now let's talk about supporting connective tissue. When we think of supporting, we're going to think about cartilage and bone. Cartilage is avascular, meaning poor blood supply. And when we have three flavors, hyaline, elastic, and fibrocartilage. Now, fibrocartilage is the strongest in the body. It's a shock absorber. So I think of the intervertebral discs, right? If this is a vertebra and this is a vertebra, the discs are between. You've heard of herniated discs or bulging discs. So the discs here are fibrocartilage. And the pubic symphysis. When you look at bones, you're going to look at the pubic symphysis right between the pubic bone. It's a vertical disc. It goes up and down instead of across. The pubic symphysis. That's fibrocartilage. And the meniscus of the knee. So the medial and lateral meniscus of the knee is also fibrocartilage. When we think of elastic cartilage, we think of flexibility. The ear, the nose, in the lungs, we're going to have elastic cartilage. Even the epiglottis of the throat. Hyaline cartilage, this is the most common type of cartilage. This is the one that's primarily involved with DJD or degenerative joint disease, also known as osteoarthritis. When people have degenerative joint disease, primarily hyaline cartilage is breaking down. When someone has arthritis of the shoulder, arthritis of the hip joint, arthritis of the fingers, the hyaline cartilage is breaking down. It's covering the very end of the bony surfaces of the joint. So this has shown up on some Connect quizzes. Blank type of cartilage is composed of a network of branching elastic fibers. I always love when they use the word in the definition, right? Okay, fibrocartilage is composed mainly of type 1 collagen fibers. They form thick parallel bundles. So thick parallel bundles is fibrocartilage, whereas hyaline cartilage is composed primarily of type 2 collagen that doesn't form thick bundles. So it could just be like that. So hyaline cartilage, if something is much thicker, this won't break down as fast as something thinner. And fibrocartilage is made up of type 1 collagen fibers. Hyaline cartilage is made up of type 2. Just remember F comes before H in the alphabet. 1 comes before 2. A lot of people supplement with collagen, protein fibers, but it's important to know, can they differentiate type 1 or type 2? Do you need to rebuild the shoulder joint or the hip joint, or do you need to rebuild the intervertebral discs, right? You're going to need different types of collagen fibers to repair different types of cartilage. Now, here's a bunch of cells, and we're looking at the blue stuff between the cells. Remember, the stuff between the cells is extracellular matrix. This happens to be the matrix of hyaline cartilage. So these are cartilage cells, and the blue is the matrix of it. Okay, when we talk about bone, we're going to be primarily talking about compact bone, which is made up of osteons. Now, I also want to talk about osteoblasts osteoclasts and osteocytes, these kind of go together a little bit. Um, Osteoblasts and osteoclasts, these two are antagonistic to one another. Osteoblast with a B builds up the bone. An osteoclast with a C for see you later breaks the bone down. It breaks it down. So we build up bone and we break it down. When bone breaks down, it then has to build up, right? So we want the breakdown and buildup of bone to be in the same ratio. If you're breaking down bone faster than you can build it up, well, that's what we call osteoporosis. So we want this to be in harmony. We call that bone remodeling, just like remodeling your home. You got to bring in the demolition crew. They take down the old sheetrock and the old stuff and they build up new. So that's the osteoblast and the osteoclast. The osteocyte, the osteocyte, here's what happens. An osteoblast, this is a type of immature cell, and this immature cell is going to make matrix. It's going to push out this cement-like matrix, this calcium matrix that's going to harden, right? So this osteoblast is immature. It's pushing out this matrix of calcium salts, and eventually this cement is going to dry. When the cement dries, that cell is now encased and stuck in this hard cavity, and it can't get out. Now it's called an osteocyte. So an osteoblast, after it makes its cement, after it makes all of that stuff and it hardens, it evolves and becomes an osteocyte. And the cavity that it gets stuck in is called a lacuna. A lacuna is the cavity that the osteocyte is stuck in. Okay? So just some terms. So when we look at bone, like right here, we're taking this section at the top. We're taking this bone, right? This is compact bone right here. All of this stuff is compact bone. It's solid right here. And this is the compact portion, right? Everything from here. This is all compact. It's all solid bone. All of this. But it's made up of these osteons. Each of these, this is an osteon. This is an osteon. It kind of looks like a tree was cut down. And when a tree was cut down, this is what it looks like, all the different rings. And those rings are called concentric lamellae. Those are the rings of the matrix that the osteoblast produced. They're called concentric lamellae. And right in the center, right there, and right there, right in the center, you can see there's like artery, vein, nerve. That's called a central canal or a Haversian canal. When you break a bone, bones bleed, right? You can see you have blood vessels going through here and nerves. It's very painful. We need these blood vessels because how else are we going to get calcium? How else are we going to get calcium in or calcium out, depending on the body's needs? We need the blood vessels to absorb those nutrients. Okay. The inside of the bone is spongy. That's called spongy bone. It has this look called trabecula. But the outer portion is very solid. It's not porous. Very solid, called compact bone. So in a model, these rings, those are called concentric lamellae. These hollowed out cavities here, those are called lacunae. And what sits inside of them is an osteocyte. Remember, the osteocyte was first an osteoblast. The osteoblast made and pushed out all this matrix, and then the matrix or the cement, the calcium salts, hardened and it gets stuck in it. And these spider-like extensions make these little canals called canaliculi. Canals called canaliculi. And it's how all of these osteocytes communicate with one another through the canaliculi. Right in the center is the central canal or the Haversian canal. Okay? So when we look at this, all of this here, this entire structure, well, that's called an osteon. Okay? If we looked here just in the center, that's the Haversian canal or the central canal. Each of these black hollowed out cavities, those are the lacunae. And then if you look closely, there are these spider-like lines, these spider-like extensions coming off. Those are called canaliculi. And the rings going around, those are the lamellae or concentric lamellae. All right, so the hollowed out blue, those are the lacunae. Okay, good place to take a break. When we come back, we'll get into the 3 different types of muscle.